Okay, everyone, thanks again for waiting. My name is Riley, and I'll be walking you through a few housekeeping items before turning it over to Kerry for the presentation. So first of all, don't worry about taking notes, as we'll be sending both the slides and the recording to you right after the webinar. Second, if you have any technical difficulties during the webinar, your best bet is to use the Citrix Help Desk. You can also tweet at us or send us an email at webinar@cbinsights.com, and we'll do our best to help. But again, we'll send everything out afterwards, so don't worry too much. Okay, so as with all of our webinars, we'll be moving through a lot of data and insights and doing it pretty quickly. But we also want to make sure that we're answering your questions and keeping this relevant. So throughout the webinar, feel free to ask us questions using the questions tab within GoToWebinar or via Twitter using the hashtag Autotech. And of course, we're CB Insights. Finally, our webinars are different than most because they're rooted in data, not punditry. I doubt that's a surprise given that CB Insights is a data and analytics company. We track every private company in the world and all the investment and financing activity related to them. This is to help our clients answer questions about major trends, competitor strategy, potential disruptors, and much more. If you're tasked with answering those types of questions and are interested in seeing the platform that Kerry used to pull today's data, just let us know and we'll set up a quick call. Okay, with that, let's introduce Kerry and get started on the content. So Kerry is a tech industry analyst here at CB Insights and is focused on automotive, logistics, and transportation sectors. He runs our weekly Autotech newsletter, which many of you already receive. His research has been published in dozens of publications, including the New York Times, Bloomberg, and others that you can see right there. Before CBI, Kerry was a consultant at Simon Kucher, and he graduated from Columbia University. All right, Kerry, take it away.
Okay, so thanks, Riley, for the introduction, and thanks to everyone for joining our Autotech webinar. Let's go through some of the different areas we're going to be covering today. We'll start with an overview of Autotech activity in private markets, and after that we'll dive into corporate competition in self-driving tech and the different investments that they're making there. Then we'll look at the startups that are tackling autonomous challenges, and next we'll explore how those trends are shaping up in the trucking and logistics industries. And then we'll be talking through some of the outstanding questions and the concerns around autonomous tech. And finally, we'll wrap up with the impacts and opportunities in other ecosystems and take some questions at the end. So let's jump into some macro trends in private markets. Before we get into the numbers, let's lay out Autotech as we define it. So in this category, we're looking at companies applying software and tech to improve the performance, efficiency, safety, and connectivity of vehicles. So what we're excluding from our data here is powertrain and manufacturing tech, as well as automotive e-commerce and on-demand companies like Uber. So here are some of the major categories that we are putting into our Autotech data. This includes assisted driving and autonomous software, driver safety tools, driving data and connected car startups, fleet telematics, V2V and V2X communications, and vehicle cybersecurity. So one thing we'd like to note here is that in that first category of autonomous software, we are including companies who are working on the quote-unquote full stack of vehicle design. So this means that they're aiming to design and produce a car that's autonomous native from the ground up. So with that, we used CB Insights data to lay out some of the macro level funding trends in Autotech. Momentum is obviously strong right now, and you can see that investment is on track for record highs in 2016. Private Autotech companies have raised over $450 million so far this year, so that run rate will break the record that was set back in 2013. And if you remember, that spike was mostly driven by a $400 million round going to Mobileye before its IPO. We've also seen some big deals so far this year, and the largest one was the $200 million Series A that was going to Zoox. When we look at the breakdown of deals by stage, it's clear that Autotech as a sector is still maturing. There's about 60% of the deals happening from seed to Series A since 2011. There's also a good deal of corporate minority rounds that are happening. You can see those being classified into that yellow other field. Cutting the deals by geography, not surprisingly, California still leads here with over 70 deals since 2011. But many international startups are also working in Autotech, and investors are funding these companies from Canada to China and Hungary. Within the US, Washington State and New York are also seeing some deals. So the investor pool that's funding this space has also gotten quite diverse. You have everyone from accelerators to more traditional VCs. We also have some mobility-focused VCs emerging. Fontanellis just closed their second fund, so they're the veteran here. Then you have some strategic stakeholders like CVCs, and here we have venture arms from both automakers and tech companies coming in. And finally, there's the corporations themselves, where we have big auto and major suppliers investing directly as well. So this is our unbundling the car graphic, where we mapped out areas where startups are targeting automotive applications. So this goes beyond some of the areas that fall into our category of auto tech, but it does give you a sense of many different pain points that startups are attacking here. And we'll be bringing up a lot of these areas in the deck, and we'll talk more about the startups in these different fields when we do. So now that we've gone through overall numbers in private markets, let's jump into how different groups of corporates are competing to put autonomous cars on the road. Within the automotive sector, we've all seen how the competition is becoming more multidimensional than it ever has been in the past. So we have new challengers coming in from the tech side in everything from electrification and sharing to autonomy. When it comes to autonomy specifically, it really has been tech corporates who've led the initial charge to develop this software, as opposed to automakers or startups. To that point, let's start off by looking at a few of the key players from the tech side. Google is obviously the veteran here. They've had prototypes on the road for almost half a decade now. Their car project hasn't been spun out into a standalone Alphabet company as of yet, but they have secured their first partnership with a major automaker in Fiat Chrysler. Google still only has a few dozen cars in their testing fleet, but this year they've started pushing them out to more extreme weather conditions like Washington State and Arizona. Tesla is an OEM that's well known for having a tech-minded philosophy. They've already deployed their autopilot feature to over 70,000 cars. Their upcoming Model 3 will also bring these features to the mass market, although that's really going to depend on their ability to scale production and meet their deadlines, which they've struggled with in the past. And of course, Autopilot has had some very publicized accidents in recent weeks, and that's raised a lot of debate that we'll touch on later. Apple is another name that's always popular in the rumor mill. By most accounts, their Project Titan suffered some setbacks earlier this year, but they're still continuing to hunt for more real estate to use as testing grounds. There's no public confirmation of what Apple's developing, but their hiring patterns suggest some sort of electric vehicle with self-driving tech. And their investment into Didi this May was also fairly out of character for Apple, as they don't usually invest in private markets. So that's driven a lot of speculation as well. Although tech companies have generated a lot of the initial buzz here, using the CV Insights Trends tool, we can actually quantify how the competitive intensity is heating up in this space. Here you can see that autonomous or self-driving vehicles used to be almost synonymous with Google there in the orange line. But the growing gap with the blue line highlights how media attention is now being spread across all the new entrants in this space. The incumbent automakers have obviously realized that they have deficits here, and that's reflected in the way they're reacting. They're obviously pouring money into organic R&D, but some skeptics might say that automakers are at a disadvantage there when it comes to tech development. So they're really pursuing all avenues, from investing in private markets to partnering with tech companies and acquiring them outright. So let's take a look at what they're doing in each of these areas. These are just a few of the headlines on the organic initiatives major automakers have announced just since May. We have everything from GM hiring 700 engineers for self-driving to Toyota funneling $1 billion into their Advanced Research Institute. So it's clear that OEMs are moving quickly to reallocate their budgets and build their own competencies in auto tech. We used our business social graph tool to visualize how automakers are investing into private markets. And what we can see here is that they're really funding startups at a record pace. And they're targeting everything from artificial intelligence and mapping to electrification and big data analytics. We also mapped out a timeline of Big Auto's partnerships and acquisitions within Autotech, and it's clear that they've picked up the pace here as well. Especially towards 2016, we've seen some landmark deals with GM Cruise and major OEMs scrambling to partner with ride-hailing companies. So let's go through a few case studies on the strategies that different automakers are taking. So speaking of GM, they've obviously made that Cruise deal, but they're also working on in-house tech with Cadillac, and they've also made an investment into Lyft. So through this, they have an initiative to start testing self-driving Bolt taxis within a year. So GM is clearly one of the companies that's moving the most aggressively to build a moat in this space. BMW has also made autonomous cars a major strategic goal. They're in the process of repositioning their EV sub-brand to focus on autonomous driving. BMW also acquired Nokia's mapping company here, along with Audi and Daimler. And they're actively seeking partners in tech to account for the knowledge gaps that they've acknowledged they have. They just announced a coalition with Mobileye and Intel, where they're planning to develop a self-driving technology as an open platform for others to use. Toyota was one of the automakers that was initially more reluctant to get involved with driverless cars, but since late last year, they've really begun committing themselves financially to it. As we saw, they're in the process of overhauling their own R&D departments, but Toyota has also started investing in everything from university research centers at Stanford and MIT to funding artificial intelligence companies as well as Uber. So we really just scratched the surface of all the initiatives coming from the OEM side, but we've outlined many of the others in our blog. So in the research of time, we'll just keep pushing ahead. Let's move on to how startups are tackling the challenge of developing autonomous cars. At first, it may have been corporations who had the resources to really make headway in this sector. But again, we can use the CB Insights Trends tool to visualize how the association between autonomous tech and startups has also started to explode over the past year. And this is reflected in how investor sentiment on Autotech is heating up. Chris Dixon from A16Z is one of the VCs leading this charge, and he believes that the democratization of deep learning knowledge has really enabled smaller organizations like startups to start tackling some of these complex artificial intelligence problems. Before we get to that, many startups are addressing more immediate needs in driver safety and awareness. So cars obviously have long replacement cycles. So even if autonomous vehicles are fielded very quickly, it's safe to assume that there's still room for aftermarket solutions for all of those drivers who still have older cars. There are several companies leveraging smartphones to make more basic safety tech like backup cameras and heads-up displays available to drivers now. Of course, these days, the companies actually developing self-driving tech are grabbing all the headlines. Zoox has been around in stealth for a number of years, and they're obviously the most well-capitalized with that big round that they got from investors like DFJ and Lux Capital. There are other startups being funded for everything from ADAS tech to machine learning for complicated urban environments. And all of these companies that you see here have seen financing just this year. And 5AI towards the bottom there actually just raised their seed round last week. Chinese corporations have also been funding a number of stealthy EV startups. So these are companies like Faraday Future, Ativa, and Future Mobility, and these are all claiming to be designing what we call autonomous native vehicles from the ground up. These companies are leveraging their parents' resources to build out their teams, like Future Mobility poaching all of its management from BMW's I program. Besides cars, companies are also applying self-driving tech to things like electric shuttles and small buses. So these vehicles take advantage of predetermined routes, campuses, and geofence locations to simplify the driving conditions that they're going to have to account for. These startups are also attracting funding from a range of VCs, corporate venture arms, and accelerators that you see there on the right. Finally, we have a handful of ventures coming way out of left field. According to Bloomberg, Google CEO Larry Page has invested at least $100 million of his own money into 2 different flying car startups. And a company called Aeromobile has even gotten money from the Slovakian government. So a little bit more out there, but definitely some other concepts on the future of mobility. Now let's dive into trucking and logistics to see how these trends are evolving in a specific field. Now in trucking, telematics are really starting to take off as a tool for fleet management because of their impacts on things like safety and efficiency. McKinsey projects that by 2020, telematics will essentially have become standard equipment for commercial vehicles in Europe. We've already seen some startups capitalizing on opportunities in commercial telematics, and there have been a number of big exits this year. We have GTCR acquiring Lytx in February, And just last month, Verizon bought Telogis to beef up its telematics unit and as well as its connected vehicle services. We also have a number of other VC-backed companies working here in this space. When it comes to automation, from a trucking standpoint, the economic incentives might be even stronger than they are for passenger vehicles. As Ryan Peterson of Flexport points out, trucking is a considerable cost input into many of the goods we buy. Although we should note that introducing self-driving tech could also put many trucking and truck-dependent jobs at risk. The highway-centric routes that trucks usually follow lends itself well to platooning concepts. So this is where multiple trucks are connected to and controlled by a lead truck. This would allow more trucks to be operated by fewer people and maximize the fuel efficiency by reducing drag between the trucks. So some of Europe's leading truck makers have already completed a major platooning trial back in April. And on the startup side, we have Pilotin, which has attracted corporate investors from Intel Capital to Magna, as well as UPS's innovation arm. Another startup named Otto is promising to retrofit existing trucking fleets with self-driving capabilities. Although they haven't disclosed their investors, Otto's team has a strong Autotech background. The funders are ex-Googlers, and its staffers are coming from companies like Tesla, Apple, and Cruise. And of course, with Tesla announcing their own semi-truck yesterday, the competition in the space will only get more intense. So once a truck reaches a distribution hub, there's still a problem of dealing with the cost and complexity of last mile fulfillment going out to individual homes or businesses. So a number of startups are applying autonomous tech on a smaller scale here, both in ground-based robots and aerial drones. Starship Technologies was founded by the Skype team, and its robots have recently started delivering food in London for Just Eat and Pronto. One point to close on is that McKinsey looked at the excess debt and debt raising capacity and cash within the logistics sector. And what they found is that the industry is sitting on a record level of dry powder. So it'll be interesting to see if that has any implications on their private markets activity over the next few years. Next, let's get into some of the outstanding questions around autonomous tech and what the key concerns are. So just as a reminder, if you have any of your own questions, we're collecting them on Twitter, so you can shoot them over to our handle at the bottom there. The biggest question is whether people are actually interested in self-driving cars, especially given the amount of investment that we see going into them. And most surveys show that people are generally optimistic about the benefits of self-driving cars. Of course, consumers in congested urban centers and tech hubs are going to be the ones who are most receptive to these things. But a common theme we see, at least in the US, is that manual driving is still a luxury that should be preserved. So they're clearly not ready to completely let go of the steering wheel just yet. It's also not shocking that in the US, self-driving tech, interest in self-driving tech, that is, falls off among older demographics. And we see a similar trend in the largest European market of Germany. However, in China, the interest is very age agnostic, so this does make sense given that Chinese consumer preferences are for being chauffeured and that they face a host of congestion issues. They also don't have the decades of attachment to the personal car that Western cultures might have, so that could be another factor there. Next, let's take a look at how the safety and regulatory landscape is looking. So before we dive in, there's a quick refresher on your screen on the different levels of automation as defined by the NHTSA back in 2013. It's not a perfect system. A common criticism is that this scale implies that development will take an evolutionary process, but it does provide a standardized set of reference points for discussion. A key decision point for everyone involved is how to actually go about developing the driverless car. We have examples all over the spectrum with companies like Tesla moving incrementally up from its public beta of autopilot. On the other hand, we have others like Google who are currently testing at level 3 with the goal of reaching full autonomy by the time they commercialize their cars. And we have others like Volvo who are also gunning straight for level 4. In terms of solutions that the public can get their hands on today, even the best systems still need a good deal of manual intervention from their users. So when Motor Trend tested some of today's semi-autonomous systems on a 35-mile loop, they found themselves grabbing the wheel anywhere from 20 to 140 times during their test drive. Now, Tesla's stance on this has been very clear from the start. As Elon Musk has said repeatedly, he believes that even early iterations of autonomous tech are still statistically safer than human drivers who could be driving distracted, sleepy, or under the influence. Another advantage he sees is that fueling this technology now will provide a more robust data set to prove that safety to regulators as well as consumers at large. As automakers start fielding more of these semi-autonomous systems, how they manage driver expectations and maintain their attention is really going to be critical. So we have research coming out of Stanford that suggests that drivers will actually become the drowsiest when they are supervising these automated driving systems. In other tasks we might normally consider to be distracted, like they tested watching videos as well as reading a passage, drivers may actually be more mentally stimulated and less sleepy. These issues will become even more critical as technology improves and driver interventions grow more rare. As overrides become less frequent, it becomes less and less likely that drivers will be mentally prepared to take over when they actually need to. Of course, we know there's been a number of tragedies lately involving Tesla's autopilot, and this is leading regulators into unknown territory and reigniting some debate over the safest path to autonomous cars. The NHTSA delayed their guidelines for autonomous vehicles yesterday, but they're stressing that no single incident should influence the process. Even so, there's no doubt that the spotlight is really intense right now, so there will be some psychological barriers that all the players in this space are going to need to clear. When self-driving accidents do happen, consumers mostly agree that car manufacturers should be the ones assuming liability. Volvo is a company that's famous for their safety reputation, and they've pledged to take the lead in accepting liabilities for their cars when they're driving in autonomous mode, of course. Volvo, as well as Google, have been vocally opposed to an evolutionary development process. They've both gone on the record stating that their only goal is full autonomy and that any other solution would be unsafe for consumers. Now, this approach is drawing a little less scrutiny right now, partly because it's not in the hands of public drivers just yet, but there's some questions around pure autonomy also. Going back to Elon Musk's point, it's true from a data standpoint that an evolutionary approach with more cars on the road can build mileage much more quickly. But both of these approaches are a drop in the bucket compared to the billions of miles that might be needed to fully assess the safety of self-driving cars across all edge cases. So it's obviously going to be challenging to validate these autonomous vehicles through test driving alone. But we're seeing more dedicated testing infrastructure coming online, where in the past testing has been done in places like abandoned former military bases. The University of Michigan just opened what they're calling M-City, which is a 32-acre proving ground for things like self-driving cars, as well as V2X systems and other connected vehicles technologies. From a regulatory standpoint, it's still very patchwork across the US states. Although, as we mentioned, the NHTSA delayed their national guidelines yesterday, we should still see those coming within a few months. But either way, the agency has said that individual states will still have ultimate authority to implement their own rules. So we can expect the legislation in the US to stay uneven. Looking globally, industry observers have looked to markets like China for advantages in regulations. We've already seen that consumer interest in China is very high, and observers point to China's central government as a tool that's able to enforce policy from the top down. But just yesterday, China also called a stop to all autonomous vehicle testing while they finalize their own guidelines. So it remains to be seen whether this will truly work out to be an advantage. Another issue is that the rise of connected and self-driving cars is opening more attack vectors from a cybersecurity perspective. There have already been a number of headlines about white hat hackers killing engines remotely, as well as disabling alarms through Wi-Fi loopholes. So this is another area where startups are looking to provide their services. One way is by running bug bounties to help automakers find bugs and vulnerabilities in their vehicles. BugCrowd is running programs for both Fiat Chrysler and Tesla, while HackerOne is doing the same for General Motors. There's also a group of startups focusing on cybersecurity for connected cars, and they're providing endpoint security such as firewalls and active network monitoring, much like other devices. Finally, let's take a look at some of the impacts that these developments will have on the auto industry and the ecosystems that surround it. In terms of direct effects, most observers see that the most direct effect on automakers is going to be the upending of the traditional car sale and ownership model. It's not unrealistic to see automation converging with things like ride sharing and ride hailing in the near future to replace personal vehicles, especially in areas like dense urban centers. However, even in McKinsey's most aggressive scenario that you see here, it's worth noting that direct sales are still going to be a significant channel into the near future. Even so, this concept of shared mobility will start eating into direct sales, especially in certain markets like Europe and Asia. Just a few years ago, automakers were looking at Asia as one of their key growth drivers, but now there's the real threat that companies like Uber and Didi will be capturing that opportunity instead. The ride-hailing companies are eager to capitalize on that opportunity, and that's why you see Uber putting resources into its own self-driving car program, even as they're burning billions of dollars to fight for market share in China. Big Auto is obviously aware of this too, with all the major ride-hailing investments that we went over earlier. These include GM with Lyft, Toyota with Uber, Volkswagen with Get, among a host of others. Suppliers are also facing a number of new challengers coming in from all sides. Instead of the traditional tiered model of raw materials suppliers going up to components and then to OEMs, we'll be seeing manufacturers sourcing hardware and software from all sorts of different vendors. Mobileye is a good example of a company that managed to elbow its way into the supplier space. It pioneered a lot of the advanced assistance hardware, and it's become a leader in this space. And now you see that a lot of the top brands are building their autonomous systems with the same hardware that's being supplied by Mobileye. One pain point that new hardware startups are looking at is the cost of LiDAR. LiDAR is a key piece of sensor gear for many self-driving cars, but they've been traditionally a little cost prohibitive to apply at scale. But now we have startups like Quanergy who are working on solid-state LiDAR systems, which could cut costs down to just a few $100s per unit. Quanergy has already partnered with Delphi to commercialize its tech. And there are a number of startups working here as well. And Velodyne themselves are responding by developing their own solid-state LiDAR unit. Tech giants are also moving in as demand for computing power and connectivity have grown. NVIDIA has made autonomous driving a major focus of its business. NXP is generating more than 40% of its revenue from automotive applications. And we also see other tech corporates like Intel and Qualcomm coming in with their own automotive platforms. From the software side, aside from self-driving software itself, high-definition mapping and navigation is also seen as a critical input, which is why the German automakers shelled out $3 billion to buy Nokia's HERE mapping unit, as we mentioned earlier. There are startups working in this field as well, like Swift Navigation, which is working on centimeter accurate GPS tech, or Civic Maps, which just got a $6.6 million round from investors like Ford and Motus Ventures. Obviously, with the digitization of vehicles, connected cars have been a major area where everyone from insurance providers to entertainment companies are looking for billions of dollars in revenue growth over the next decade. Here we also have a strong group of startups that are going after immediate opportunities. So these are things like connected car adapters and driving data apps. And this has been one of the more long-tenured fields in Autotech. And now many of these providers are using their central positioning to build out app and analytics ecosystems. So these can be B2B applications like fleet management and business expensing, or consumer-facing use cases such as on-demand repairs and smart home integrations. One impact from the proliferation of connected tech is that it's fueling the adoption of usage-based insurance. You can see that in the blue, a fifth of US drivers now participate in some form of usage-based program. And these are coming from dedicated UBI providers like Metromile, as well as programs from a number of incumbent insurance providers. Obviously, these insurance carriers are seeing this as one of the key levers that they can use to appeal to younger generations. With all this bandwidth coming into the vehicle ecosystem, other companies are also solving for constraints in infrastructure capacity and gaps in communications coverage. So these will also open up new pathways for V2V and V2X communication that will allow for further developments in network cars, things like smart cities and beyond. Once automation and connectivity become commonplace, the opportunities within the entertainment space are also going to be huge. Ernst & Young estimated that if all US driving time were suddenly shifted into watching video, that could translate into $20 billion in incremental revenue for the entertainment industry alone. And we've really only scratched the surface of all the fields that could be impacted. For the past century, the automobile has dictated so many aspects of our businesses, our infrastructure, and our culture. So whatever the time frame may be for the future of Autotech, we can expect it to change the landscape all over again. Great, so that wraps up all the content we had for you today. We'll close Okay, so the first question is, who do you see as some of the top investors in this space? Well, we definitely mentioned Andreessen Horowitz earlier. As we said, Chris Dixon has been very bullish here, so they've been fairly active. A16Z has invested in autonomous driving with Comma.ai and last mile delivery drones with Dispatch. Fontinalis Partners, the VC that's affiliated with Bill Ford, has been around since 2009. So obviously they're more veteran investors here. And they've also invested in companies like ZenDrive, Telogis, and Nutonomy. And outside of those, we've seen Intel Capital actually being one of the most Autotech investors. They've invested in Peloton, Inrix, as well as a few other companies. And we've got Qualcomm, NEA, and all those other investors we mentioned ramping up their activity here as well. The next question we got was, you talked about how technology companies are moving quickly into the automotive sector. What are some of the challenges that they might face? Yeah, so obviously they have a lot of advantages, and people naturally assume that these tech companies are going to be better at developing complex software and iterating more aggressively. That may be true, but from the manufacturing standpoint, there's a question of where their capacity will come from in the near term. So they'll face significant capex if they want to start building out their own production lines, or if they want to find a contract manufacturing partner. OEMs like BMW are refusing to become the Foxcons to a company like Apple, and the existing contract manufacturing base is something like less than a percentage point of global production. So this is why even the CEO of Google self-driving car project, who used to run Hyundai America, has said that tech companies in general underestimate the complexity of building cars. There's also the fact that Big Auto, with their global distribution networks and Dealer networks, though unloved, admittedly, they still have many more global touch points to reach consumers for direct sales, which, as you saw with that McKinsey graphic, will still be relevant into the near future. Let me see if there's any last questions we can get to before we wrap up. So one investor asked whether we might see trucking adopting high levels of automation more quickly than passenger cars. So that's a good question, and it depends a little bit on what you're defining as high levels of automation. If you're talking about full automation, trucking seems as though it would be fairly complex with all the edge cases of hauling different loads, driving at full load versus driving the tractor unit only, selecting appropriate routes off highway. This might need some improvements in smart infrastructure from things like weigh stations and bridges. But if we think about autonomous more generally, as we said, the monetary incentives for trucking are very high. And if we include concepts like platooning and autonomous highway cruising, that would cover the vast majority of most trucking legs. So from that standpoint, there's definitely some signs for optimism there. And it would also help with the driver shortage that many countries are seeing and truckers' quality of life. So I think there's a case there for rapid adoption.
Unmuted.
Okay, everyone, thanks for joining us today. As a reminder, we'll be sending out the slides and the recording, so look out for that in your inbox. We'll also do our best to reach out and answer any questions that we didn't get a chance to address here today. And don't forget, we're also a software company with the most comprehensive platform to help you draw your own business-specific insights about what's happening in the private markets. Let us know if you want to take a look. Have a good day, everyone.